Welcome back. In this session, we will continue with the discussion of convolution. Let's start. So the goal here is to perform the convolution between two sequences x of n and h of n. And let's call it, let's suppose the convolution is y of n. Or we can say how to compute the output of a system whose impulse response is h of n and input is x of n. Then the output is y of n. And we can obtain the output of this system y of n by performing the convolution between x of n and h of n, and this star denotes the convolution operation. And you know we can write this convolution operation like this, so we can write y of n like summation k running from minus infinity to infinity x of k h of n minus k. Or we can also write the convolution between x and h like this. Can write it summation k running from minus infinity to infinity h of k x of n minus k. Now what's different between this summation formula and this summation formula? The only difference is here the n minus k operation is performed on h sequence. Here the n minus k operation is performed on x sequence. That's different between these two. In other words, we can perform the convolution between x and h either using this summation formula or this summation formula, and this is referred as the commutative property of convolution. This is referred as the commutative property of convolution. Commutative property of convolution. In other words, we can take either a convolution using the first summation formula or second summation formula. So this is how we can perform the convolution between these two x and h sequences. Now, first of all, the given sequence was x of m and h of m, but here in this summation, we replace it x of n by x of k. Now, what's the difference between x of n and x of k? These are one and the same, means x of k is same as x of n. Only difference is we replace it n by k. That's the difference. So in this summation, we replace it simply n by k, means x sequence is same as x of k, and similarly h of k is same as h of n. In other words, we replace it n by k in h of n. All right. Now, have a look at these two summation formulas. Now, what is the goal? First of all, what's the goal? Goal is to obtain y, means calculate. The goal in this convolution is to compute y for different values of n, and we want to obtain the value of y for all values of this time. Means what is the value of y as n goes from minus infinity to infinity. That's the goal in this. So our job is to compute the output or simply the convolution between two sequences for all values of time. For all values of time, and is compute y for all values of time. That's the goal. Now, if you have a look at this summation formula, if I say any instant means value of y at any instant of time, so let's suppose when n is 5. So the formula will be, the summation formula will be k running from minus infinity to infinity x of k. If I use the first summation formula, 5 minus k, as I put instead of n, I replace n by 5. Or I can also write it like this: summation k running from minus infinity to infinity h of k x of 5 minus k. Now replacing n by 5 in the second formula. So whether I use this or this means running the same. All right. Now have a look at this. Now you can see the variable in these summations is not n. Variable in this summation is not n, but the variable in these two summation is k. You can hold it. So the variable in these two summations is k instead of n. And what is k? What's difference between k and n? In this x of k, k is same as n, means we replace k by n, or it's simply this in this h sequence we replace n by k. Now what is this? This 5 minus k here, 5 minus k is h of 5 minus k and x of 5 minus k. Or simply in general, what is this x of n minus k? What's this operation? But now to answer this question, let me tell you first what is actually convolution? It's not an ordinary operation. Means it's not an ordinary operation like addition, subtraction, multiplication, or division. It's not that. It has actually four operations embedded in it. So you can see the one operation here is looks like you are multiplying x of k and h of phi minus k. You are doing the multiplication of another operation. You can have a look is you are performing the summation operation when you multiplied the sequences. That's how you obtain the values of y. So to answer this, what is this n minus k or simply phi minus k here? You can see there are actually how many steps are involved in this convolution operation, and there are four operations. If you check, there are actually four operations. Now what's the first operation? First operation is the folding operation. Now whether I use this summation formula or this summation formula, so folding you have to do. Now in this you are doing the folding operation in h, in this you are doing the x half. So first you obtain h of k, or you can say in the second formula you can say x of k. You obtain x of k. How you do that? You replace n by k, and then you perform this folding operation on this h or x sequence. In this you perform that one h sequence, in this you perform that one. That means you replace k by minus k in this, or you can say you replace k by minus k in x. That's what you do in the first in this first. So this is the first operation, means you are folding the sequence, either h in this or x in this. Then what you do, what's the second operation? Now the second operation is simply the shifting operation. So the second operation is shifting operation. So this is actually shifting operation. Once you folded the signal, means this is how folding is also referred as reflection. So you replace k by minus k, or x by minus k. So this is the first operation. Second operation, you shift the operation. Means you shift the sequence and obtain h of n minus k or x of n minus k, depending upon which summation formula you're using. You are this or this. So the second operation is shifting operation. So, and you obtain h of n minus k, or you can say we obtain x of n minus k, depending upon which summation formula. Again, depending upon whether you are using this summation formula or this summation formula. So you do the shifting operation. Now you will do the shifting operation either on h or x, not both. Remember, this is why I write this or also, because you can use the summation formula. So this is the second operation. So if n was equal to 5, so if n was equal to 5, the example that I took from there. So if n was equal to 5, this means you will put n equal to 5, and this will be n minus 5. So this will be x of minus k. So you will shift the h of minus k sequence by 5 sample points, means you will shift it towards the right. In other words, if n is positive, you will shift the sequence towards right. If n is negative, you will shift the sequence towards left, whether h or x sequence. This is the shifting operation. Now, why we want to do that? Well, this will be clear once we solve an example. Why we want to perform this shifting operation? This will be clear, and I will answer this question there. And the third operation that we perform on this to obtain the convolution, once we have shifted the sequence, then we perform the multiplication operation between x of k. Now this means simply multiplication and h of n minus k, depending upon how much shift you are taking. You can take any value of this n. So you are performing this, or you can say we are doing this operation multiplication between x of n minus k and h of k. So if you are shifted, if you are folding first to x instead of y, so you will perform this operation. So the third operation that you can say is the multiplication operation. Multiplication between x of k and h of n minus k. Remember that, and is a shifted version. Or you can say x shifted version of x and simply h sequence. So this is the third operation. Now once you have performed this third operation, fourth operation, then what you do the addition operation. So the fourth operation is once you have multiplied the corresponding sample points of x of k and h of n minus k, then you do the addition operation means you perform the summation k running from minus infinity to infinity x of k h of n minus k for a given time shift. You perform this and you obtain the one sample value of y. You obtain the one sample value of y, and there's another sample value. N can be any value, means from minus infinity to infinity. So this is how you obtain the one sample point of the output sequence, or simply the convolution sequence. So this is over. Now you can see how many operations are actually embedded in this convolution operation. So this is not an ordinary operation. The first operation is folding operation, second is shifting, third is multiplication, and the fourth is addition operation. So to obtain a one sample point of convolution, or to obtain one sample point of the output, we actually have to perform four operations. One is the folding, second is shifting, third is multiplication, and fourth is the addition operation. All right. Now, in the next session, what we'll do, we'll solve an example. We'll solve an example to illustrate these four operations. All right.